If the area of a circle is increasing at the rate of 24 meters squared per second at the instant it has a radius of 4 meters, find the rate at which the A, radius changes, and B, circumference changes. Let's start by writing down the information that we are given. We have the rate at which the area changes, A prime or dA dt, since it is changing with respect to time. It's increasing, that will make it a positive 24 units of area meters squared over time seconds. We are also given the radius of 4 meters. For part A, we want to find how the radius changes. We know how the area changes, so we need to relate the radius to the area. The area of a circle is pi r squared. This is our related variables equation. If we take the time derivative of both sides, we will get the related rates equation. Taking the derivative with respect to time on both sides is indicated by a prime on both sides. Every variable here is implicit with time, so every variable will have a prime when you take its derivative. On the left side, the derivative of a is a 1, but then times a prime. On the right side, we start with the power rule, bring the 2 down, multiply it with the pi, subtract 1 from the power, and then multiply by the derivative of the inside, which will give us an r prime. This is our related rates equation. We can now plug our numbers into this. We have a 24 equals to 2 pi times r is a 4 times r prime. So 24 equals 2 times 4, which is an 8 pi r prime. And we can solve for r prime by dividing both sides by 8 pi. 24 is divisible by 8, and that becomes a 3 over pi. So r prime, or dr dt, will be 3 over pi, and units of r, radius, in meters over t time in seconds, meters per second. For part B, we want to find how the circumference changes. We now have the rate of the area as well as the radius, so we can relate the circumference to either of those two. It'll be simpler to relate it to the radius because the circumference has a simple relation to the radius. It's 2 pi r. There's the related variables equation. We can take the time derivative of both sides to generate the related rates equation, indicated by a prime on both sides. The derivative of the left will be a 1, but then times c prime, since it's implicit. And on the right, the derivative of a constant times r will be the constant 2 pi, but then times r prime, because it's also implicit. Every variable will get a prime when we take a time derivative. There's our related rates equation. We can plug numbers into here, so c prime will equal to 2 pi times the r prime we had just found, which was 3 over pi. The pi's can cancel since one's in the numerator, one's in the denominator. And c prime will be 2 times 3, which is 6. So therefore, c prime, or dc dt, will be 6 units of circumference, that's a length in meters, over time, that's in seconds here. And there's our c prime, 6 meters per second.